Okay, we can get started. Hello, good afternoon, and welcome to our Uptake webinar series. We are happy to have you here, and today is the first webinar that we have in 2026. We are very happy to host this webinar with the participation of three distinguished guests that I will introduce later. I have a couple of slides as a background to our presentation today and also in general about the project, the Uptake project, and also the institution who coordinates the project, CMCC. So as you may know, this is a part of a monthly webinar series on carbon dioxide removal or CDR. It happens every second Wednesday of the month. So you should register for these webinars and you will receive notification about the next webinar, which will be in February and so on. It will be at 2 p.m. Central European time, which is now, and it's an online event. Your registration is required to participate in these webinars. This webinar is part of a project called UPTAKE, which is coordinated by CMCC. CMCC is a leading research center focusing on understanding the interaction between climate change and society. We have about 450 researchers and staff across 3 institutes and 3 centers and 4 programs. We are, as you can see on the map, in several cities and locations across Italy. The 3 institutes that I mentioned, they have been listed. One is basically devoted to the economic and policy analysis of climate change. One is on climate resilience and one on Earth system predictions. We have also 3 cross-cutting program, integration of planetary and industrial carbon cycle that I am directing that program. We have a program on predicting socioeconomic outcomes of climate change and the global coast as new frontiers. Together, we are coordinating this Uptake project, which is a European project about bridging current knowledge gaps to enable the uptake of carbon dioxide removal methods. This project has about 20 partners across European countries. As you can see, they have been listed on the right side. It started in 2023 and it will go until 2027. The overall budget of the project is 7 million euros. To enhance interaction with the partners of the project and also interested parties outside the project, we have developed a platform, an interactive platform, which allows users to learn about the activities of the project and also interact with the members of the consortium. To join this platform, you can scan the QR code here. It's called Uptake CDR form. And you can enjoy the range of posts that we have here, from the publications to the events that we post and inform people about all CDR events. We also want to share with you an upcoming event that we are, as CMCC and Uptake, are hosting, the 4th International Conference on Carbon Dioxide Removal, that formerly was known as International Conference on Negative CO2 Emissions. It will be hosted by Politecnico di Milano from 10 to 12th of June 2026. To register, you need to submit your abstract by the end of this month, and then it will go through evaluation and we will let you know if the papers are accepted for the conference, so you can participate in June in this conference. Today we are happy to host this webinar, which will talk broadly, but not only, about the paper which titled Energy Demand and Savings Opportunities in the Supply of Limestone and Olivine-Rich Rocks for Geochemical Carbon Dioxide Removal. The speakers are Stefano Caserini from University of Parma, Stefano Cappello from Limenet, and the moderator and another speaker is the Serena Di Marco from Politecnico di Milano. Actually, it will be moderated by Stefano Caserini. Sorry for the typo here. To interact with the webinar and ask questions, we ask you please to use the Q&A option, which is at the bottom of the page. And you can type your questions there, and we will try to answer the questions during the webinar. But if some questions remain, we try to move them to the CDR stakeholder forum and ask the presenters to answer those questions there. So it's a good idea to join the platform, and also you will be able to watch these webinars later on also, as it is recorded now. So as I mentioned, the next webinar will be on February 11. So stay tuned for that and register for that webinar too. So with that, I will stop sharing and I will hand it over to Stefano to start the webinar. Thank you very much.
Hello, everybody. Thank you for the invitation. So I share my presentation. The idea of my talk is just an introduction to Serena De Marco that she will discuss in detail, she will present in detail the paper you mentioned. The idea is that I will provide the context of the paper. The research developed within the Geochemical project will briefly provide an overview of all the researches we have made on this on ocean alkalinity enhancement. And then after Serena De Marco that will present the paper, there will be a talk of Stefano Cappello. So just one slide to remember that we are here because we know that all pathways that limit global warming to 1.5 require a very large amount of carbon dioxide removal. So the achievement of the well below 2 degrees, the aim of the Article 2, the Paris Agreement, is fundamentally dependent on our ability to remove gigatons of carbon per year from the atmosphere. So in this, starting from this, we developed the Marisanus project. The Marisanus part means that we want also we like to face also another problem, big environmental problem, is the ocean acidification, because it's no one known, but the variation in the ocean acidity has been already very relevant, something unprecedented in the last 65 million years, according to the IPCC report on 1.5 published in 2018. So in the Marisanus project, we started in 2019. We try to consider different kind of activity, different kind of researches, and I will just present some of the results we have published. The main publication of today is the publication on energy demand and severe opportunity of limestone and Olivine-Rich rocks supply for geochemical carbon dioxide removal, will be presented by Serena. But I will just mention two papers written in red here, and also I will just skip all the other paper. So we started in 2019 and we developed with Giovanni Cappello in particular and Dennis Ross-Murray process for negative CO2 emission and the production of hydrogen from biomass, ocean liming, and CO2 storage. I don't have the time to go into detail. You can find all the detail in the paper, but it's a combination of existing technology. It's a combination between bioenergy and CCS and ocean liming. And the idea is to to reduce the cost of the process producing hydrogen. Doing the energy and material balance of the process, we have seen that this process requires a lot of limestone, about 1.7 ton of limestone per 1.5 ton of CO2 removed from the atmosphere. So if you want to remove gigatons of CO2, we need gigatons of limestone, and all the operation needed for using the limestone. We consider limestone. We know there are other candidates for ocean alkalinity enhancement, olivine, magnesite, bauxite, but we believe that the calcium hydroxide, we worked on calcium hydroxide producing starting from limestone. And then in the last part of our research, we consider the addition of non-reactive alkalinity, what we call the buffer accelerated weathering on limestone. The idea is not to discharge carbon dioxide on seawater in order to remove carbon, but do the reaction before and discharge an equilibrated alkalinity. And now I know that Limenet is working on other idea to do also alkalinity enhancement. But maybe Stefano will present these new approaches. So in the project we studied how to disperse to discharge calcium hydroxide on seawater. We consider ship's wakes first of all, and in this paper we try to assess the potential of maritime transport for ocean liming with using existing ship or new dedicated ship. We try to understand the rate of discharge, the combination between the rate of discharge and the speed of the different kind of boats, and the efficient management of slaked lime within the boats, and also the limiting energy use and cost of this discharge. We consider different kind of fleet or size, but just I want to mention that all this data has been the input of modeling exercise made by the CMCC that was focused on the Mediterranean Sea. This was a very detailed simulation made by Mombe Butechon, Thomas Lovato, Simona Masina, that suggested the simulation that there is a potential of doubling the uptake of CO2 by Mediterranean Sea, at the same time neutralize the ongoing acidification trend that we are facing in the Mediterranean Sea. So it was a very interesting exercise. Then we studied also the fluid dynamic of the slaked lime discharge at sea, considering the different kind of fluid dynamic modeling, this different discharge rate. So there is a lot of interesting thing here. And also we try to make some calculation if it will be possible to discharge slaked lime using aircraft. We conclude no, it's too costly, too expensive from an energy point of view, but we make some calculation. And also rainbowing, that maybe has some possibility more than aircraft. But we published also a paper of rainbowing, but we believe at the end of the night that discharge on ship's wake is much more efficient. This paper is something that is related to the paper that Serena will present. We publish a paper on the availability of limestone and other raw material for ocean alkalinity enhancement. We consider geographic information system data and the different kind of limestone, and limestone is one of the most common rocks on the earth, and we consider the pure carbonate outcrops that they are much more easy to mine. And we concluded that there is a very large availability of limestone within 10 kilometers from the coastline. So, and a lot of this limestone is in an area where there is bare ground, where it is practically possible to mine all of this limestone. So we talk, there are many gigatons of limestone available within 10 kilometers from the coastline. Then we consider also the feasibility point, from a feasibility point of view, the fact that we need an upscaling of mining and transport activity for large scale ocean alkalinity enhancement. But if we consider the global level is not a relevant upscale. Why? Because if we consider world production of mineral raw material in 2015, we discovered that actually we are already producing 7 gigatons of limestone per year. And then we also exploit 7 gigaton of coal, 4 gigaton of petroleum, and 3 now or 4 gigaton of natural gas. So if we know that if we want to stay well below 2 degrees, we need to stop as soon as possible the mining of coal. So the interesting point that exploiting and transporting gigatons per year of limestone for oceanic enhancement could be a way to re-employ the equipment and manpower currently used in the coal sector. So the excavation and transporting of limestone could be a way to do the just transition, because it's to re-employ all the manpower currently used that will lose the work with our transition. Also from from the point of view of the maritime sector, a post made by a Twitter post, there were Twitter by Bill McKibben said that if we switch to renewable energy, the number of ships crossing the ocean will fall almost in half. And we also demonstrate with the previous paper that a large part of the ships that travel around the world are used for transporting fuel. And so this will end, so we will have a lot of ship that we could use for discharging alkalinity in the sea. And then I'm going to finish one of the part considered for the feasibility of alkalinity enhancement is the energy cost of quarrying, beneficiation, and processing of the different mineral. But now my time I see is finishing. I just want to mention that we've made also calculation from the life cycle analysis of all the process, and also I believe that Stefano will discuss the last part of the research we have done that now are done by Limenet. So I leave the floor to Serena now because my time is ended.
Okay, thank you. I start talking about the relevance of the research by adding new information or something new, different compared to what Stefano said. The relevance of this part of research can be summarized in three main points. The first one is that, of course, if we want to develop mineral-based CDR strategies in the future, such as ocean lining and enhanced weathering, of course, we need to consider the order of magnitude of the energy demand required for mining and processing raw materials in, of course, large quantities, amounts, and these CDR relevant materials are limestone and olivine-rich rocks. So this was the first point, leading us to consider this, to deepen this part of the research. And the other point is, of course, the need to optimize the energy demand of industrial processes is not restricted to CDR purposes, but it's a general concept. So we can develop this need, we can see these needs also in the reduction of emission in general. And the other point is that recent researches and globally, overall, we know that the chemical effectiveness of ocean liming and enhanced weathering is influenced by the target grain size. And this is internally linked to the energy demand of comminution. So it is important to, we recognize the importance to deepen this part of the project inside all the other researches going around ocean liming and enhanced weathering. The main aim of the research was to analyze each macro phase of the raw material supply chain from an energy point of view, but with a specific focus on the two CDR relevant raw materials, so limestone and olivine-rich rocks. And each of these macro phases, so surface mining, comminution, and long-haul transportation, were analyzed, subdividing them in other subphases. The structure of the research followed some consequent steps. The first one was a literature review with the aim to collect data and information about the energy consumption relative to each stage I showed before, and of course the energy saving strategies we can apply to each stage and substages of the raw material process chain. The other step was to analyze the data collected in order to come out with two new relationships linking the energy demand of comminution to the target grain sites. The third step was to make evaluation and calculation about the effective energy saving potential of each phase and subphase. And the last step was to make calculation about the use of electricity in the future to grind limestone and olivine-rich rock for ocean liming and enhanced weathering purposes, including and excluding energy saving action. In this slide, I just show the formulation of the relationship we use to derive the energy demand for comminution and how it is linked to the grain sites. And in this slide, there is the theory, the basic theory or the basic relationship we use to derive the total energy saving opportunity. And as you can see, one of the most important component of this relation is the practical energy saving opportunities that is internally linked to the capacity to implement best practices and research and development findings. For what concerns the last part, the projections were made calculating the energy demand for finally grinding limestone and olivine-rich rocks on the basis of future CDR target we want to achieve and improvement on the energy efficiency of grinding. And we consider a time frame going from 2025 up to 2050. And we made this calculation considering two kinds of scenario. For what concerns the first scenario, it was called high requirement scenario, and the CDR target we supposed to achieve is relative to the 1.5 degree with no or limited overshoot pathways, whereas in the low requirement scenario, the CDR target are those relative to the 2 degree pathways, but all these data were taken from the State of Carbon Dioxide Removal first edition. In table 1, instead, you can see our assumption with regard to the share of CDR exclusively sequestered by ocean liming and enhanced weathering within the time frame we considered, the share of deployment of ocean liming and enhanced weathering, the energy efficiency excluding and including energy saving strategies over the time frame, and most importantly, the maximum energy efficiency we need to achieve, we need to perform if we want to obtain the gain. In this slide, I show you an overview of the data collected. So it was 990 for olivine-rich rocks, totally, of course, and 212 for limestone. Here, I show the new relationships for comminution, depending on the limestone and the olivine-rich rocks, and these were derived by calculation made on the data available. And here there is a table where I summarize the total practical energy saving opportunity relative to limestone and olivine-rich rocks, depending on each stage of the raw material process chain. But in general, you can see how big, how consistent is this total practical energy saving opportunity. And the difference between limestone and olivine-rich rocks depends on the total availability, global availability of limestone, that is much larger than olivine-rich rocks. Here I show the same results for what concern the road transport, the means of transport, and road transport in comparison with the other kind of modality we analyzed exceed in total practical energy saving opportunities because of this is related to the higher energy consumption. And in this slide, there is the results relative to the future implementation of ocean liming and enhanced weathering. For both the scenario, we calculated the total CO2 removal required to implement ocean liming and enhanced weathering, the total amount of calcium carbonate required, as well as the total amount of olivine-rich rocks required to perform ocean liming and enhanced weathering. And this plot, you can see this plot at the bottom, whereas in the upper part. At the bottom, there are the plot of the calculation regarding the energy demand, excluding energy saving action, and including energy saving action, and this lead to a practical minimum of energy. The range of reduction in the electricity demand for comminution is relevant because it can span from 35% to 55% in the case of high energy efficiency scenario, and it is lower in the case of low energy efficiency scenario. So to conclude, we already know that ultrafine grinding can be considered as the most critical activities along the analyzed raw material supply chain. What we did in this research is to update data and make new calculation. And at the end, of course, our study confirmed that fine and ultrafine grinding is the most critical activities. But the other side is that even if we know that, and our study confirmed this statement, the other aspect to consider is that if we could invest in best practices and research and development over the next decades, we could support the competitiveness of ocean liming and enhanced weathering, because in doing that allow us to lower consistently the energy consumption and required to carry out the phases we considered, of course, in the supply chain, raw material supply chain. And this is possible because if we invest in best practices and research and development, we could bring the maximum level of practically achievable energy efficiency For the grinding phase, of course, it is specific for these activities. This maximum level can increase from 3% to 10%, and this this allows us to achieve a percentage going from 33% to 55% energy reduction. Thank you very much for the attention.
Thank you very much, Serena. So now, Stefano, if you can present your slides. Thank you.
So thank you very much. And sorry, this is my email. Okay, so first of all, thanks for this opportunity to talk in this webinar. And I'm Stefano Cappello. I'm the CEO and founder of Limenet. Limenet is an Italian startup that has basically has been founded to demonstrate, industrially speaking, what Professor Stefano Caserini and other fellow colleagues started as a research project. And the goal of the company is try to industrialize new technologies for removing carbon dioxide from the atmosphere using these techniques of ocean alkalinity enhancement. So we are a company that has been founded in 2023 that has now 22 people working full time and has raised a little bit less than 10 million euros as a risk capital, and a little bit more with contracts and other grants. So yeah, this is the team. We are located in North Italy, in Lecco, Lake Como, and yeah, so we are growing as a company, and we are structured as an EPC company, so as an engineering company. The goal, I don't want to repeat, but is to try to avoid the catastrophes of climate change. And in particular, one of our goals is also try to understand how to deacidify the ocean somehow with ocean alkalinity enhancement. But try to be more realistic and pragmatic. The realism is that, first of all, we don't need to remove, we need to remove carbon, but first of all, we need to decarbonize our industries and so to reduce basically the carbon that is emitted into the atmosphere. And there are a lot of industry that are hard to abate, so hard to decarbonize, and two of them that are something that we are working on, and in particular one of it is the lime and cement production, that those accounts for basically 2 gigatons more or less of CO2 per year, so it's quite a lot. And what is in common with those two industries is that limestone is one of the main components of lime, basically is the main component, and of cement. So that is why limestone, so this carbonated rock that Professor Stefano Caserini and Serena De Marco explained before, it's one of the most crucial, let's say, feedstock that we need to understand how to process in a decarbonized way. So the technology and the concept that you saw it maybe before in a more academic way, and now it's more in an investor way described, is how it's possible, to produce and to remove carbon with a rock, so with limestone. The concept is quite similar to what's happening in nature during the weathering of carbonated rocks that we saw in a cave where there are stalagmite and stalactite. So basically calcium carbonate or limestone with CO2 and water basically reacts, and with thousands of years it weathers the rock, and it transforms the rock into a solution of bicarbonates. So those bicarbonates are basically ions that are then with the rivers basically discharged into our oceans, and in our oceans they remain for thousands of years, so for a geological time frame. So it's something that's happening in nature, and if we want to, to industrialize it, we need to find a way to basically to make it happen in industrial case. and with a cheap cost and with, let's say, energy sustainable consumption. But this is basically the concept that we are talking in this webinar today. How this can be basically industrialized. Professor Stefano Caserini was mentioning before, basically the journey that basically we are following started a few years ago in 2018 with the concept how to weather limestone in an easier way and how to make ocean liming, so how to remove carbon with the ocean. And what we discover is that the main concern and the main bottleneck is the feedstock, how to do ocean liming, ocean alkalinity enhancement. That could be olivine, or could be lime, or other alkaline feedstock, so other material that could be used in order to capture CO2 with the ocean. And so in 2020, 2021, we started to think, okay, but how are we able to process this lime and to produce it without emitting carbon in the atmosphere? And that we came with a process. That's what we see in this slide. So basically, we start on the middle bottom. So we start with limestone, and then we calcine the limestone with an electric calciner. So basically, it's a kiln, it's a oven that heat up limestone to 900 degrees. Then limestone is split in two parts, so CO2 and lime. Half, so 50% of the lime is combined with the CO2 that has been produced in order to produce that bicarbonates that I was describing before. And then we have the other 50% of lime on the bottom left that could be used in order to make ocean lime. So that could be used as a sponge to capture the carbon from the atmosphere. So this is basically the concept that we started with. Then, as Professor Stefano Caserini was mentioning, there are also other ways how to produce alkalinity. So a feedstock that could be used in order to make ocean alkalinity enhancement, such as sodium carbonate, and maybe more in the future, let's see. But this is basically the concept. So to produce a net zero alkaline feedstock to spread somehow in the surface of the sea, and to make the surface of the sea be a sponge to capture the carbon. So this is basically the project we did so far in Italy in order to demonstrate the process we described before. So this is a pilot plant able to basically process 100 kilograms per hour of CO2. We did in Sicily, in Augusta, and we did a test of a batch of more or less 20 tons of CO2, just to understand if it's working or not. And of course, it's working. And we also got a certification for a controlled process to understand according to ISO 14064 if it's working, and if you can measure how much carbon is being transformed. And then we are building this electrical calciner by our own design in order to prove the transformation of limestone. You can see here on this on my hands. So on the left, you have a fine material of limestone, and on the right, the powder of lime. So you need to think that 50% of the white powder should be used in order to remove the CO2 coming from the rock itself. So basically, can be used to make ocean liming the 50% remaining. More than this, we also, as a startup, as a company, it's also really important for us to describe people and the local community what we are doing. Since now it's small pilot, but when we think that we need to remove carbon or to decarbonize cement or lime production, we need new industrial plants, so new areas where big industrial plants need to be built. So it's important for us to understand how the local community may reply to these kind of new processes, but we got really good feedback. And this is also Professor Caserini on the up left talking in Milano about climate change with Professor Daniela Bass. This is, we are going at the end of my talk. This is the render of this small pilot we wish to build as soon as we obtain the permits to to be done. And this is the first of a kind concept to produce net zero lime that could be used in order to make ocean alkalinity enhancement. And this is the first step, of course, because for maybe the audience, ocean alkalinity enhancement is really growing as an ecosystem and as a new technology pathway in order to remove carbon. So the technology there are now can be different than the technology we will have in the future, because we will know more about the impact of this feedstock on the sea. So we may discover other ways more efficiently to do that. But this is where we need to start, because if not, we are just speaking and just speaking on paper, but not on the real ground. Just to conclude, so the advantages we believe to brings is that we need, of course, to reduce the environmental footprint of all industries, in particular lime and cement, before, of course, making CDR. And the CDR with ocean alkalinity enhancement is really interesting, since it allows basically a new type of geological storage, or storage in general, that also has a co-benefit to acidify the sea, at least where you do that. And finally, that of course is compliance with all the regulation regarding decarbonization. And finally, but not least, is where is used lime. But some of you maybe are curious, where is used lime? Lime is used in so many industries, not just in CDR, but also in iron and steel, in construction, agriculture, water treatment, food processing. So it's quite common to find lime in our daily life, but maybe we are not aware of. And finally, lime and also other new alkaline feedstock can be used to make CO2 removal with carbonation, with storage of biogenic carbon, or with ocean liming. And this concludes my speech. That, of course, is just a point in this webinar, but we need really to think to be net zero as soon as possible if we want to survive in our planet. Thank you.
Thank you very much, Stefano. Very nice presentation. And I think today was a special day because we had the full chain from theory to practice. So it's very interesting to see how some of the ideas basically grow from the research and become actual projects. So thank you very much for all of our panelists to share their thoughts. So this part of the webinar, basically we open it for question and answer. So I would ask the participants, please use the Q&A section at the bottom to post your question. I don't know if there are questions already in the panel. We can start the discussion, and then I will read some of the questions from the Q&A section. Yeah. Okay. So there is a question on the limestone, and actually you touch on that, Stefano, at the last slide. Like limestone is being used in the cement industry. So if we're gonna go larger scale with this type of technologies that you are talking about, do you see any competition with the cement industry wants to use the original limestone, not necessarily maybe the green lime or so?
Yeah, sure.
Yes, that could.
Okay, no, yeah,
Go. Let's go.
Sorry.
No. You first.
Stefano.
You first, Stefano. Go.
Okay. No, that's of course really important, because all of decarbonization and CDR must not take away resources for decarbonization. But regarding limestone, basically 30-40% of limestone, when is grinded, is too fine to be used in cement production industry or lime production, traditional production industry. So it's disposed in the quarry. So basically it's taken away, it's milled, etc. And then it went back to the quarry again. And that is something that we saw in all the limestone producer we spoke with. It's between 30 and 40%, then it depends of the the quarry. But what we believe, and also what is our design of the green calciner, is to use that 30-40% in order to avoid any competition. And also Stefano Caserini showed before, the availability of limestone is incredible high, and also the production of limestone is incredible high. So it's 7 gigaton per year, and I mean, it's really a big, huge number. But please, Stefano, if you want to add something.
Yes, there could be a problem of competitivity, but we have to remember that from our process, for all the process of cycle enhancement that are based on limestone, the major part of the cost the costs are related to the calcination of limestone. This is the real problem of ocean liming, because you need a lot of energy to do the calcination of limestone. So I believe that this is not something that will interfere with the cost analysis, particularly in a way important. So that could be a problem, but we need to upscale the production of slaked lime. So the production that is used now is not so important compared to what we have to do.
Yeah, thanks. So there are a couple of questions. So I try to summarize them. But first is, what is the current technology readiness level, TRL, of green calciner and seawater-based calcium bicarbonate storage, and how scalable is it to the industrial level?
So the calciner now is a TRL 5. We are building a TRL 6 by July 2026, and the storage part it's a TRL 7. So it's quite higher since we started before. And the goal is to integrate those two in a TRL 7 pilot plant I showed you before. Because I read as well, so how stable and conservative operating at temperature. Okay. The goal of the electric calcining is also to basically to absorb more power when there is more power. So this is one of the advantages. And so, for instance, right now in Europe, more or less the break-even using an electric calciner or a fossil fuel calciner with methane is more or less 8 euros per megawatt hour, respect the cost of methane and the ETS price. So it's really depend about the energy that you are using, if it's sustainable or not.
There was also this question. The next question is about, do you use renewable energy for mining of the limestone, or how is it mined?
Actually, Limenet now don't mine limestone, but the suppliers we are working with, they don't use renewable energy for nothing, because basically they are using grid energy that's 36% renewable in Italy, Stefano. So unfortunately now the economy is not using 100% renewable. If you can do PPA, but for a startup, it's too early, that question.
Yes, but we have to consider that now we are scaling also enhancement, but we are quite confident. Then, as an example, in 2035, 2040, when we have to reach the very large size of carbon dioxide removal, the electric grid will be decarbonized. It's much of the most simplest thing to do to decarbonize electricity compared to household heating or transport and so on. So now I know that excavator and mining is not based on renewable energy. Maybe in 20 years' time, the pattern will change. But please remember that for this process, as I said before, the real energy cost is not for mining, it's for a calciner. So it's important that we have a green calciner that could rely on renewable energy. Then also could be used, I know that the capital cost will increase, maybe could be used during the day, because we will have a lot of photovoltaic energy, and we know that in all the very advanced decarbonized scenario, the problem will be that during the day we will have a surplus of renewable energy. So maybe we can use this kind of technology when the price of electricity will be almost zero. Not now, not in a 5 years time, but maybe in a 15 years time, this would be a scenario that would be efficient for production of slaked lime, decarbonized slaked lime.
So there is a question about the cost. Do you have an estimate of the cost of 1 ton of removed CO2 through this process?
So right now the estimation, so the cost basically depends on the size of the plant, the electricity price, and if your labor cost is Italian labor cost, for instance, or US labor cost, or I don't know, China labor cost. So these are the main three variables, but energy cost is the main driver. So for instance, in Italy, where we want to build this facility, the cost, but it's really small facility as a pilot, is more likely 1,500 euros per ton of CO2 removed. But it's incredible high. But this is a pilot, so take in mind that this is a pilot. Based on our estimation, we see that if the energy price, if the energy cost is more or less $60 per megawatt hour, the cost to remove 1 ton of carbon it's a little bit higher than 250 euros per ton as first price. But then we hope to increase the efficiency and to decrease the cost and to be more likely 170 to 200 euros per ton of CO2. Unfortunately, right now, this technology cannot allow you to be 30 euros. This is our experience because this is reality right now.
Also about the side effects, there was a question about, have you done some studies to see maybe the potential side effects on the marine biodiversity or basically marine ecology when you apply this?
Stefano, maybe do you want to?
Yeah, but there are many studies that have been published in the last 5 years. I also want to answer to the question before that, say what's happening outside Italy or Europe. So we started working on ocean climate management in 2018, 2017, I don't remember well. But then there was very few research group that were working on ocean climate management. In the last 5 years, a lot of work has been done. In the last 2 years, in particular 3 years now, there is a very interesting literature. So there is an increasing interest for all the way in which we can remove carbon from the atmosphere using the ocean. So the pattern is changing. There is now is considered the old carbon removal by the ocean one of the most important strategies. So there are, for this reason, a lot of literature there is on the different kind of impact on copepods, on the marine biota, and they are made in laboratory sometimes. They are made in mesocosm, so it's not easy to translate the effect on the open sea water. But the main conclusion now is that depend of the rate of the discharge, the impact. So we know that the discharge, liquid lime as an example, is something beneficial for the ocean because it contrasts acidification. The point is that at the point of discharge, you don't have a very high rate, otherwise there could be a counter effect. You will increase too much the alkalinity, you will increase the pH too much. But this is something that could be managed, I believe, because at the end of the night there is a strong dilution in the ocean. So it's just a matter to consider to have a slow rate of dispersion.
Yes, thank you.
We don't have sorry,
Sure.
let me add that we don't have all the answer now. There is a lot of research ongoing, also for the problem of precipitation. Okay, we have if we discharge with a very high rate, we have the risk of precipitation of carbonates. So it's something that we have to avoid, but it's
Right.
something we are also working.
There is a question about other minerals. Have you considered other minerals? There are some suggestions here, pyrogenic minerals with limestone, dolomite, which could have more value in the future, then lead to more policies to get limestone. How are you prepared on that, as now China is extracting more? I don't know if you have thoughts on that.
Not particularly. I mean, I don't know now about China, the recent China trend, but remember that we don't discharge limestone because limestone water is super saturated respected to carbonate. So we have to produce something that is reactive as a liquid lime and discharge the liquid lime. So we considered olivine. And I believe that for our point of view, is much more efficient limestone because also it's much more available. And if we want to upscale this strategy, we need the availability of limestone in many parts of the world, not just where there are few deposits.
Thanks. So I think we kind of answered most of the question. There are, of course, some questions that maybe we can follow up. And as I mentioned, we can continue on the platform. I don't know, we are getting close to the top of the hour. If we can maybe have a round and see everybody maybe your takeaway about the future of this technology, what you think are the main barriers and main enablers, basically. What do you see the main obstacles in larger scale deployment of these technologies, and what do you see as a positive sign also maybe in the horizon? So maybe we start from you, Dr. Caserini.
Yes, one of the main constraint is from, I believe, is on the regulatory point of view, because we have to do experiment, first of all, and then you have to get the permission for discharging as liquid lime. And this is something that in some part of the world could be not so easy to obtain. The permitting procedure could be very long, and this could disincentivate the investment. But I believe that when the research and development of this technology will be more advanced than now, maybe we will have more answer to provide to the policymaker in order to have a better regulatory framework.
So Stefano?
Sorry, and the last point,
Sorry,
MRV.
sure.
I don't know, Stefano, if you want to elaborate on MRV, this is another point.
Yeah, no, but the main concern and bottleneck now are permitting a legal framework. So this is what we find out as Limenet, but also as all companies in the world. So it's really a struggle to be, the innovators in that field. That's of course something that also solar panels innovators, wind farm innovators brought 40 years ago. So we are finding the same stuff. So of course, to scale up this technology must have a rigorous permitting framework, and also regarding MRV, so the monitoring, reporting, verification part. It's really important to invest capital to decrease the uncertainties, since, of course, being an open ocean alkalinity enhancement has a lot of uncertainties, but we believe that the potentiality are even more. That's why we are betting on this pathway. And so, of course, I saw also in the comment that the Trump administration, of course, made a really pushback in all climate stuff. So it's really horrible, but we believe that, of course, we need to do that. So it's just, but also for geopolitical reasons. So why we need to also electrify system, also for geopolitical reasons. So to be independent. So we need to self-produce our electric energy, and then we have our electric cement plant, electric calciner plant, etc. Because we don't need to buy a commodity from outside countries. Unfortunately, the carbon price is not yet a world commodity, so we hope in the future it will be, because as soon as there will be rules, entrepreneurs, investors will making business, they will make happening stuff and things. So this is our hope, so that regulators put this this rail.
Thanks. Serena?
Yes. From the part I talked about, I find interesting a question about if the mining part is not so decarbonized, the level of effectiveness in these very important strategies such as Limenet. If the mining part is not very considered and is not so fully decarbonized, there should be a decrease of efficiency. But I hope that with my presentation, it could be clear that we have a lot of strategies also in the mining sector, even if in the mining sector is rely more than other sector in the use of fossil fuels, so it is not so flexible. But there are ways, there are methods to change direction, to change, to switch from fossil fuels to other kind of technologies. So the important thing is to invest, as I showed before, invest not only in the grinding, which was the main part where energy consumption calculation was focused, but also the mining part, the mining sector have a lot of new ideas and strategies, innovative strategies to provide us hope in the way of decarbonization.
Thank you very much. Very good insights, and also MRV that mentioned briefly. I think that's the big topic. We are hoping to have a webinar this year focused on the MRV and maybe MRV on this sector. And yeah, this is a very big topic and growing interest in this topic. So thank you very much, everybody, and the panelists for great discussion and presentations. And thank you, the audience, for staying with us. We will see you all next month in February 11th for the next webinar in this series. Thank you and have a good afternoon. Bye.
Thank you.
Thank you.
Bye.
Bye-bye.
Bye bye.
Bye.